Hello there, you're welcome to my channel. If you're new here, it's so nice to have you here. Feel free to subscribe, like. We're currently on the JavaScript series, and this is yeah, we've gone through a lot of lessons, and I've decided to stop counting. But of course, I'll keep them in my titles. All right. So if you want to know the particular lesson that we are on, you could just go through the title. But for this lesson, the title is replace loops using recursion. Recursion is a special subject in programming, all right? It's the concept that a function can be expressed in terms of itself. To help understand this, start by thinking about the following task. Multiply the first n elements of an array to create the product of those elements. Using a for loop, you could do this. So this simple function here calculates the products of the first n elements of an array. All right. So the first n element, it could be whatever you pass in here. So if you pass in 4 here, it's going to be the first 4 elements. If you pass in 5, I believe we're familiar with this. With this, we've done something like this in our previous lesson. Getting the product of a couple of elements in an array. All right. So however, you notice that multiply this, this function, all right, equals this, but then using n minus 1 as the second argument multiplied by the n minus 1th element of the array. Okay, that may be a bit confusing, but we'll get to understand this more. So that means that you can rewrite multiply in terms of itself and never need to use a loop. Interesting, right? Using the recursive way. So this is what it looks like. So we have another function, then if n is less than or equal to 0, we simply return 1, all right? Because obviously if n is less than or equal to 0, that means we are not calculating the product of any elements. Remember that n is supposed to represent, the first n element of the array that we need to get the product of. But then if it's less than or equal to 0, that means there is nothing we need to calculate, so we just return 1 simply. But if it's not, then we go ahead and, call the function in the words that I use here in terms of itself. All right, I'll call it again inside itself. So that's why it's recursion. We're calling this function inside of its own body. So the recursive version of multiply breaks down like this. In the base case where n is less than or equals 0, which is this, it returns 1. But for larger values of n, it calls itself, but with n minus 1 like we saw here. The function call is evaluated in the same way, calling multiply again until n is less than or equal to 0. At this point, all the functions can return and the original multiply returns the answer. Oh, that's quite a lot, right? And the original multiply returns the answer. Recursive functions must have a base case where when they return without calling the function again. So this is our base case here. If not, if this base case was not here, it's gonna keep running and running and running and crash your browser or whatever you're using. Okay, or it's gonna just give sometimes so on your code editor, it may just give an error. All right, forgotten another error. So it says that we must have a base case when they return without calling the function again. In this example, when n less than equal to 0 is our base case, otherwise they can never finish executing. So we have a challenge right here, but before we get into the challenge, I would like us to, break down this example and try to make more sense out of it. Yeah. Okay. So let's go ahead and console.log the results multiply. Let's give an array that we want array to a 4 element array. And let's say we want to get like the product of the first three elements, which is 3 times 2 times 1, and that is 6. So how does this work? Let's take it one step at a time. So on the first step, it's a recursive function, so it's going to call itself a couple of times. So let's just go through it. So the first time, it's going to call this, and from our function body, the first thing that's going to happen is that it's going to check if n is less than or equal to 0. In our case, it is not so. It's going to go ahead and run the else part, which is simply going to return, call the function again, but in a slightly different way. Multiply. So this is how it's going to look like 1, 2, 3, 4. But the second argument, I can see, is going to be decremented by 1. So 3 minus 1 is going to be 2. And then it's going to also multiply by the n minus 1th element of array. So in our case, it's the second element because 3 minus 1 is 2. And then of course the element with the second, or with an index of 2, is 0, 1, 2 is 3. So let's just go ahead and just put 3 here. Okay, so in order to execute this line, it's going to have to call multiply again. So that's like a second call, which I'll just put under here as number 2. And then it's going to call, okay, it's going to, of course, go ahead and check if n is less than or equal to 0. It is still not. So the second part of this, if else block is going to be executed. And then we have something similar to, okay, please, 3, 4, multiply. And then this time around, it's going to be n minus 1, 2 minus 1, which is 1. And then this part is going to be ARR 2 minus 1, right? Which is because we are still on this function, right? We are still on this call. 2 minus 1 is 1. And then the element with the index of 1 is 2. So let's go ahead and simply have 2 here. And then it's still going to, of course, this tree is still hanging up here, right? So we're still taking this tree down here. Okay, because what we did here, we only this function, right? We're still multiplying by 3, so we just broke down this function here, this particular call, and then it gave us this. But then we still have our tree up here, so we'll add it to the end. All right, I hope that makes sense. Then the third function call, because we still have a call here to treat. So using our body here, the body of the function is going to check again if n is less than or equal to 0, and it is not so. It's going to go ahead and call the method again, or call the function again. This time around, 1, 2, 3, 4. Of course, the array is still the same, but then the second argument is decremented by 1, making it 0. Finally, we are at 0, and then n minus 1, 1 minus 1. Okay, we're going to multiply by the n minus 2 minus 1's elements. So that's ARR1, and that happens to be, no, sorry, 1 minus 0. Okay, sorry about that. We are taking care of this right now. So it's going to be 1 minus 1, 0. That's like this. So it's going to look like this actually. But then we should just put in the element with index of 0, which is 1. And let's not forget 2 times 3 up here. We're going to bring it down. 2 times 3. Perfect. And then one last, okay, we still have, a call here. So we're going to break that down again into a fourth call. And this time around, n is 0. So it's simply going to return 1, right? So we have something like this: 1 times 1 times 1 times 2, and that is what gives us 6. So if you multiply this, so that is how the recursion is working, or that's how the recursion works. So I believe that we have some understanding of this now, and it's now safe for us to get into the challenge. Let me just undo all this. Perfect. So they were asked to write a recursive function that returns the sum of the first n elements of an array. So I believe this is quite simple. Our base case, if n is less than or equal to 0, we want to return 0, of course, because this is sum, alright? It's not product. Else return some. Okay, let me do a little challenge here, right? So if you're watching this, can you just give me the line? Yeah, this line. What do you think I should put in here? I'll just give you 2 seconds to drop it in the comment section. All right, that's more than 2 seconds. Okay, let's see some our array n minus 1 multiplied. Is it multiplied? It's not multiplied. Plus array n minus 1. So let's try something out. Console.log. So let's put in let's say 1, 2, and 3 with get all three of it. And we have 6. So it works, right? Okay, let's try something else just to be sure that this is actually working. So we have 4 and 5, and then let's calculate all 5 of them. 15. Okay, 5 plus 4 is 9, plus 3 is 12, plus 2 is 14, and plus 1 is 15. Wow. So this works, and just imagine how few lines we used to get this done. I think I love this recursive method. If we're using if we're using a for loop, it shouldn't take us so much lines either, but I think I like the recursive method. I'm tempted to just see what that would look like. Let I equal to 0. I is less than ARR. Okay, I is less than N actually. I plus plus. Mm, it's not so much either. I think we have something like that in the example. Here's the difference. Oh no, I think I prefer the recursive method. So if you, I would like to know what you prefer. You're watching this right now. Just let me know. Which one do you think is preferable to you? Which one do you like better? Is it the recursive method or the normal for loop? I think for me, I'm already a fan of this recursive method. So let's run our test to be sure that we are on track. And yes, we are. Wonderful. Thank you so much for watching. I'll see you in my next video. Don't forget to like, subscribe, and share to your friends. Bye bye.